Good evening, everybody, and welcome to week 3 of Blockchain Fundamentals with Dr. Rich Lane. And you'll be hearing my voice, Shane Murphy, a little bit tonight as well, as I'm the MC and host. As always, tonight we will give you 2 to 3 minutes for everybody to get settled in, get their glass of wine, their cup of coffee, their drink of water in front of them. And just in the meantime, introduce yourself on the chat. You probably know the drill. You've probably all been here at least one of the last couple of weeks. But we welcome you anyway. We hope you are not as cold as we are here in freezing Melbourne this week. Maybe you're from somewhere overseas. Maybe you're from a northern part of Australia where everything's warm. Thank you for the salute, sir. John is here hiding behind the IT Masters logo. He's here to look after the chat, so you'll hear from John quite a bit. But as I said, we will give you about another minute and a half to 2 minutes for everybody to pop on in. And until then, you'll get a bit of radio silence from me. Speak soon. Okay, I will let Peter know just before we go on that we don't use the hand raise function in this. If you've got a question, and I'll do all the introduction material in just a second. If you've got a question, if it's a question for our mentor, Dr. Rich Lane, to answer, then you put that in the Q&A section. And if it's general chat for everybody else, just type your message in the webinar chat and make sure that your webinar chat is set to everyone when you do it so everyone can see and interact with you. You can see we've got people from all over the world tonight. I did see somebody from Algeria where it's 47 degrees, considering it's about 10 or 11 here in Melbourne at the moment, or in fact, I'm in a place called Ocean Grove. About 3 weeks ago, I was in Luxor in Egypt and it was 40 to 44 degrees. But so I'm really, I'm understanding what 47 is like. That must be super hot over there. You've got people from Warragul, Canada, all over the place, all over the world, as always. And we're really excited about that and really want to welcome you along. As I said earlier, my name's Shane Murphy. Tonight is week 3 of our 4-week Blockchain Fundamentals course, taught by Dr. Rich Lane. Just a bit of housekeeping before we get into the guts of things. As I said before, remember to put your chat in the chat and your questions for Dr. Lane in the Q&A section. We can usually get to most of the questions, not all of them, and some of them will encapsulate if we get the same question in 3 or 4 different ways of saying it as well. And I'll probably ask the questions of Rich as we're going along. If there's something you want to share with the rest of the crew, stick it in the chat. We often find that the chat has some really good information going. Sure, we are experts to a certain extent, and when I say we, I mean Rich, but also you guys out there probably know at least as much as we do on quite a lot of these topics, and we're always really impressed and happy to see the depth of knowledge and everybody helping each other in the chat. So I hope you're all well and looking forward to a nice warm evening by the video screen. Really, the only other thing I've got to say this week is a reminder that there is a survey that's available when you log on to the platform, and we'd really like your input on the survey, because apart from it, telling us how you feel about this course and how it's run, it's also really important to get a little bit of information about other short courses you might like us to have a look at. We're always coming up with ideas ourselves, and we're very interested in seeing what's out there in the market. I can foreshadow that this year we are planning to have a short course on project management and probably one on AI later in the year as well. So that's probably the next 2 short courses. But anyway, those announcements will be for later on, but it's always nice to let people know. And if you do put some answers there about sort of courses you like, feel free to fill in the text box with a little bit more detailed information. By the way, Mahbub, we don't use the hand raise because if you've got a question, you stick it in the question or stick it in the chat. Okay, having said all of that, it's really time to get our gear on. And I'd like to introduce Dr. Lane for week 3. How are you tonight, Rich?
I'm good, thank you.
I'm metaphorically waving to you.
Yeah, oh, hello. Well, I'll just kick it off. Thanks for everyone coming. Yeah, week 3. I've been following all the posts in the forums, and thank you for the great questions and some great discussions. So it's really great to see people are embracing the the topic and the subject, and seeing as we tried to portray what blockchain can do outside of cryptocurrency. So with that, let's get to it. I'm just going to do a quick introduction. My name is Dr. Richard Lane. I'm currently Chief Technology Officer at Orange County Data OT. I did my doctorate at California Southern University, graduated last year. I did my MBA with IT Masters as well in 2017. I'm currently teaching at a different university. I'm going to skip a few things here. You've heard me say this before. I've got 3 blockchain patents, and I won Blockchain Business of the Year in 2019. So maybe I know something, but there's definitely a lot about blockchain I don't know. And hopefully this course, as what I'm about to say here, is an introductory course to blockchain technology. And what we're trying to do here is answer the question that if you're at a party or a barbecue and someone comes up to you and says, so what is all this blockchain? How does it work? You have an understanding of that, and you can describe how things work, why it's called block and why it's called blockchain, and the elements to that. So hopefully you've looked at modules one and two. And if you haven't, or you're looking at the recordings, I encourage you to look at those first. These are sequentially getting more difficult, but they are building on the previous weeks. So with that said, who gets value from this course? And I say this every week, we're not here to sell you cryptocurrency. We're not here to recommend anything like that. We're showing you how you can use blockchain in other ways. Well, actually, how blockchain was originally perceived and how it's being used in other use cases. So people that might get value from this, people that, business leaders that are looking for new potential ways to do things in their industry, general learners, and then some people that already happen to know something about cryptocurrency or blockchain and want to deepen their understanding. I'll quickly go over this. Week one, we looked at actually what is blockchain, some early concepts, notable prototypes, and then some real world use cases. Last week, we looked at how cryptographic hashing works, why it's called blockchain, what elements are there, excuse me, and what actually is in a block. We also touched on things like the mempool, the concepts of consensus mechanisms of proof of work and proof of stake, the differences to that. And I saw a question this week about saying how blockchain is quite energy intensive. And I encourage you to look at module 2, and I actually encourage you to look at proof of stake, because it gets a bad rap, but it's only because of particular blockchain networks that use a proof of work that has energy efficient. So I encourage you to look at that. And then obviously we looked at some trade-offs. This week, we're looking at different architectures, private, public, consortium, and hybrid. We'll break all that down. Something you may have heard of but might not know anything about is smart contracts. I'm hopefully going to break that down and talk about how it works, why they're called that, what's in them, what's the mechanism that they do, and what's their purpose. We're going to touch on, and we have touched on this previously in other weeks, but what exactly is data storage on chain and what is data storage off chain, and what's the differences? And then we're going to touch on how this can integrate to business systems, APIs, middleware, and how all of these connect to each other. Really quickly, next week, we're going to get our most advanced week. We're going to touch on zero knowledge proofs, some security considerations, how we can interrupt between different blockchain systems. I know there were some questions previously regarding that. I'm going to summarize everything and have a closing discussion. So this week, blockchain, and I've done a few slides here based on some discussion that was done for some modules, and I wanted to sort of take a little recap because, as I said, this particular module is building on what we've learned in week 1 and week 2. So if you're at this point, we can sort of say, blockchain, what can we do now? Well, we know blockchain can prove something exists without actually showing it. And that's done through immutability. And in particular, if you're doing something that's hashing something that's offline through a hash that's put into the network. We can also show that something existed at a period of time. And that's done through hashing something, putting it in a public blockchain, and I'm just generalizing here, and a timestamp is added to that. A timestamp is automatically added to that. So you can prove at a particular point, and using the example we did last week, you could write an invention, or if you wanted to claim that you invented something first and potentially copyright it to yourself without showing you what exactly that is, you could hash whatever that document is, hash that image, hash that database, hash your code, and put that hash in the blockchain and say, I invented this. And there's actually been use case examples where people have put a blockchain element or a hash on something like Twitter and said, I'm proving something, but I'm not telling you what it is. And later on, when you want to prove that you knew about this thing and created this thing, you could point to that as at a point of time. So we also know that through hashing, modification cannot happen. Really quickly, if you hash something and make a modification to the product or item that you've hashed, the hash will not match. Even the slightest modification will make a different hash. So you can prove something is as it was. We can point to it in a public arena, meaning it's potentially in a decentralized blockchain network, Bitcoin, Ethereum, and we can point to it and say, there it is over there. Everyone can see it. I'm not controlling it. It's decentralized, and we can point to it and say, there it is, and no one can say otherwise. And we know it's decentralized. So decentralization brings trust to untrusted people. And what that means is in a network such as Bitcoin, for example, we've got various nodes that are contributing to the network in a decentralized manner. There's governance rules around that. I won't get into that this week. We've talked about it. But because of that, we can prove that no one is lying and everyone's having a copy of the same truth, which is the ledger that's on all the different nodes. So what does this mean? Well, with those concepts that we just mentioned, we're actually proving something exists. So there's a concept called proof of existence, and it's not similar to proof of work and proof of stake as a consensus mechanism, but as a concept of you're proving something exists at a certain point, at a certain time, in a certain configuration. And I did a post on the forums this week, and there's a very, very good article, and I strongly suggest you look at it regarding proof of stake. And I've written here that from their definition, that refers to the method of proof of existence, stating that a fingerprint hash of a document is generated, for example, using a SHH-256 algorithm and is subsequently embedded into the Bitcoin network to authenticate documents off-chain. So in this particular case, for that particular article, they were saying exactly what we've been talking about, and that proves something exists without even showing you or showing anyone it exists. And it only needs to be shown at the point of when you feel you need to show it. And then there's a real world example, which happens to be called proofofexistence.com. I have no affiliation to this at all, but I wanted to show you that really quickly because there was some questions last week at the end of the module that said, well, how do I do all of this? How do I put a message into blockchain? How do I sign something? And most of that's done with a wallet, and you can put messages in as part of a transaction. But there is this service, and I've just gone to my browser here, Proof of Existence. And if you see here, this is a service that someone has built. According to the research I did, it was built in 2014. And it's one of the early examples of this where you can select a document and have it certified. So you could, in this particular case, pay about 45 Australian dollars, depending on the exchange rate. And if you're watching this in a year's time, when Bitcoin might have gone up or down, you might be laughing, but these are certifications. So these are the hashes of a document that's gone up. And then if we click on this, we can actually see in this particular case, this is a blockchain, what do you call it, browser or chain viewer. So you can see the transaction, you can see the op return, which we've been talking about, where the actual transaction happens. So this, I encourage you to have a look at this site. I don't necessarily recommend spending money on it. You can if you really, really want to have a go. There are other ways to do it, but this is a good example. And there's actually some source code here. If you're very, very technical, you could have a look to see how it's done. And there's some documentation. So it's a very good example. Encourage you to have a look at it. So, excuse me, this week, what are blockchain architectures? Well, blockchain isn't one size fits all. There are different blockchains. There are going to be more blockchains in the future. I dare say that what is considered blockchain now and what was considered blockchain 10 years ago is vastly different. So with that said, and again, in 2025, there are 4 main blockchain types: public, hybrid, consortium, and hybrid. And what do they mean? Well, first of all, what does architecture mean? If we're saying blockchain architecture, you might think it's all the same and it's all just blocks and chains, which we talked about. And the examples that we did talk about last week were mainly around Bitcoin, just because it's one of the most popular and easy understood. But architecture refers to how the blockchain is built, how it's governed, and how it's accessed. So who can read and write? And I know what you're about to say, read and write. I thought this was decentralized. Well, the next one is who controls this network? Centralized versus decentralized governance. And governance just in this case means who's controlling the network. Decentralized blockchain like Bitcoin, their governance is baked in through the consensus mechanism. But if you were to download, for example, the Hyperledger Fabric, which is a type of blockchain that you can just download and run it on a few servers in your house or your office, you'd have your own little centralized blockchain system, and you could do whatever you wanted on that, and you could possibly even excuse me, do some transactions and things like that, and have a look at the blockchain explorer if you so wanted to do that and set up your own little governance. But as we've talked about, the trust in that would be based on the person that's running it. So blockchain kind of only works if you can trust it. And if you remove the decentralization, you have to put the trust element somewhere else. And that's going to be on the people that are running it. So that could be a government, whether you trust the government, but a central authority that has some sort of trust would need to run it. So how consensus is achieved, there's different types. We've talked about that. How the data is stored and how it's shared off-chain versus on-chain. And there's other examples of that we can look at and we talk about later in this chapter. So what are public blockchains? We've been talking about them for the last 2-3 weeks. They're mostly open to everyone. I'm going to say mostly, but they're pretty much open to everyone. They're fully decentralized. They really need to be in order to be called public. They have high transparency and immutability, meaning no central person is controlling it. It's out there, as I pointed, and you can point to it in a public setting and say, this is this, and no one can change it. And examples of that are Bitcoin and Ethereum. And then, just as I've said, private blockchains controlled by one or limited organizations. You might have a government organization that has several particular branches, and they want to run some sort of governance, some sort of trust between elements, between parties. Um, it could be done like that. Um, and then it's usually permissioned access, meaning if it's private, you're not going to allow just the general public to get onto it. So perhaps certain people have access, certain don't people have access. Um, it it can be faster because you don't have the overhead of a consensus mechanism, and it's always different. You actually can trust because you can control the nodes on the network. You can actually bake trust in because you control the network. So it can be faster, but there are examples of very, very fast public blockchains. So take that with a grain of salt. Um, and then trade-offs, centralized is obviously less trustless, meaning trust has to be baked in. It's not going to come as part of the network. It's less transparent because you can't point to it in a public setting. It's 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 there, and if you want to prove it's there, someone has to tell you it's there, unless they open that up, and that's not necessarily um, a private blockchain at that point. So consortium blockchains are controlled by a group of trusted entities. This could be, for example, a hospital network around the world that wants to share some sort of data that they may or may not trust certain hospitals, but they don't necessarily want this information on a public network. So they put up sort of a consortium network that allows people to contribute and put data into an immutable state or however they're using it, and have a consortium of people that are contributing to a particular blockchain. Another example might be, I know De Beers, the diamond, I don't know if you want to call them manufacturer or conglomerate. They do have supply chain versions of this. And I'm sure some of that is based on different vendors, which would make it a consortium blockchain. So there's share control and governance. It's often used in finance and supply chain, the exact examples that I just talked about. Hyperledger Fabric is quite popular. It's I don't know now, but I know at least in the last 5 years it was backed by companies like IBM and NTT and some big major players, especially when blockchain was the flavor of the month a few years back. It was definitely, and DLT, which is another particular topic, was very, very popular. And Hyperledger Fabric was a key player. They also had quite a bit of money at the time in terms of investing in certain projects. So it was quite a popular platform. Um, so the setup and coordination, you have to define the rules to play. So you don't necessarily, you can configure it, but then you have to talk to a whole bunch of other people and say, this is the rules that we want to play with. Do you agree? And you have to have sort of a consensus on the rules of this blockchain and how it's going to work. So it can be a bit, coordinating can be complexity, and still partially centralized because you are having these rules, you're having limited people that can enter. So it is somewhat centralized. Then we have hybrids. So this is a mix of public and private elements. And what this means is that you could potentially have, and I'm just using an example, some parts that need to be in a blockchain that are sensitive, and other parts, such as a hash to prove that it exists, in a public element. So you can keep private data sensitive in a private blockchain part, and just prove it exists in a public ledger. So ensuring the integrity as it, or the immutability is another word you could use. It is flexible and scalable, but obviously, grain of salt. You still would have to integrate with that, and you still have to run another network. So it does solve some problems in different ways. And I've put a comment here that each architecture solves different problems. Choice is dependent on trust, control, and transparency needs. So there's not one particular flavor that you want to roll out. There's also one point that I didn't make, is that if you use public networks, you do have to pay things like gas fees. You have to pay to the network. if you are running your own blockchain, you don't have to, there's no on tracks. In most cases, there's no on fees to do transactions. And obviously there's cost of electricity and things like that. And you could bake it in certain other things. But for the most part, it's cheaper to run, but harder to set up. And I've done a slide here because I think it's important that you might go to a meeting one day and someone says that's not blockchain. And a lot of purists and a lot of people that have originally created blockchain say, no, I'm sorry. If it's not decentralized, it's not blockchain. So true blockchainists or blockchain people say it must be centralized, it must be permissionless, and it must be censor resistant because that's the elements of blockchain. That's what, if you look at the Bitcoin white paper, what it was trying to achieve. So anything out of that, and I don't agree or disagree, I'm just here to report and show you my research. But so people also say that systems with centralized controls are just distributed databases. So some people might even argue that if you're not, you can't call blockchain something unless it's all these elements. So and again, the last thing there, Bitcoin is often seen as the only pure example in this group. So if you are at a convention and you start talking about DLT and someone puts their hand up and says, that's not blockchain, you'll now be able to have a slide that tells you you are correct. But it's like the old term of when I was young, and I'm showing my age, people would say, what's the difference between a hacker and a cracker? And there was a big argument based on that. And at the end, who really cares? It's a little bit of a misdemeanor. So and at that point, we've just inserted time for a break for questions.
Excuse me, I put my audio on. Okay, so we've got a couple of questions here at the moment. Paul says, but a blockchain is still a distributed database just with a particular architecture. Is that right?
So is it a distributed database? Well, yes and no. It has other elements to that, and I encourage you to look at the week one where we talk about the other elements that are associated to that, especially the consensus mechanism and how blockchain came from different pieces of technology. It wasn't just invented one day. There was actually some key points that even the white paper for blockchain cited to say, well, I took encryption from this, I took concepts from here and wrapped them all together to make blockchain. So some people might say that that is the case, but I think the previous slide actually talked about that where it's not just a distributed database. So
how do blockchain technologies intersect with cybersecurity practices and principles?
I get this question. It's a good question. I get it a lot. Don't assume because you hear the word encrypted that it's safe. If you don't keep your wallet safe or you have a weak password, or you share your key on a public network somehow, or you get hacked, it's just as secure or insecure as anything else. So it's not security is baked in terms of you can't really attack the front of it. And I say that in 2025, but the weakest point is probably going to be, passwords or user error or something like that. And it's just as secure as anything else. And you just have to take the same amount of care that you would with anything else.
Okay, Brian asks, doesn't a file contain a last access property? Therefore, this changes, so the hash would change?
No, not unless you touch the file and modify the file, or copy the file, and maybe there's exactly what that question answered, where the last access or copy version of it. But as long as you don't move or touch that file, generally it won't change just by itself. So if you opened it up in Word and saved it again and Word changed the last update date, yes, 100% that's a different file, even though you've not changed any um, particular characters within it. So if you just left the file alone, no, it wouldn't change.
Okay. Is blockchain the underlying technology of decentralized autonomous organizations, in brackets DAO?
Um, yes, it's built. They're built on top of. I don't think they would exist without. So yes, 100%.
Right. In hybrid, separate chains, a private chain and a public chain?
I'm sorry, what was the question again?
Yeah, when you're talking about hybrid blockchain environments, do they have separate chains? One's private and one's public, for example?
Yeah, yes. I mean, you could have the same chain. Like if you took the source code of a public network and ran your own version, yes, you could have the same protocols and everything, but they would be different networks. But you could also have two different chains, um, and you'd have to build some sort of, excuse me, middleware to connect them to. But yeah, you could have two different if you wanted to.
A couple of questions are both pretty much the same, which is, can you provide some examples of the widely used private blockchains in Australia, for example? And a
Um,
follow.
Actually, very good question. And I would encourage you to go look at the forums from week 2 because I posted up, I think, possibly 5 or 6 examples of some Australian ones, uh, showing some private blockchains. So yes, there's some good examples. And just if you don't have access to that and you're looking at the recording, there is an identity network, well, an identity blockchain, I should say, called Miko or Miko Me, Miko.me as the URL. And that's actually built in Australia. So, and I know the CEO quite well, so transparency there. But that's one. And there was a there's a I don't know the name of the game, but the company was called Virtually Human, and they make a NFT horse breeding game, which sounds really strange, but you can actually have different NFTs and they have different properties, the NFTs, and we'll talk about NFTs just later on what they are. And you can, through smart contracts, breed them and mix them together, and it makes new NFTs with different properties. And I believe you can race them and put them out to stable and do all these weird things. I've not done it, but that's also an Australian company, and they make quite a bit of money doing that. I forget the name of it, but the company's called Virtually Human. So again, not an endorsement. I don't know who runs it or the people behind it, but it's a good example.
David's mentioned something called Red Belly blockchain in the chat. Not that as in,
That's a like 100% that's an Australian based blockchain, but they I don't actually they do run it, but I think it's a public system. But you can I've actually used it for 6 years or something, and I downloaded my own versions and ran it in previous roles. But that's also a good example of a blockchain network that's built in Australia. It's not necessarily a chain or something you could point to, but I think they do have a main net now. I know they had a test net and I've got a main net. So yeah, that could be a good example as well. Yes.
how do public, private, and consortium blockchains handle things like security, speed, and control differently? And are there particular types that work better or best for different industries with strict rules?
Um, this is more of a case of to answer this question, if you remove blockchain from that and didn't even use it as an example and just looked at how would these businesses function if they were to do this on paper, for example, if you could define that and how they would exchange information, then obviously you wouldn't do it on paper, but you can actually define how businesses and people on the network would interact with each other and how they would swap things. So once you've figured out the business, you could apply it to the most appropriate blockchain that fits that model. So we know, for example, if it's healthcare, you have private information, but you want to make it available. You might need to show some information to uh, like Medicare or something to the government or something to um, maybe a financial institution to do payments, but you don't want to show everything. So if you could figure out those elements and then figure out what blockchain fits best to solve, it might not solve all those problems, by the way. It might only solve the immutability part of it. You could use it that way. So there's not one particular thing I could point to for that industry. Like this particular product works perfect for this industry. There's not really like that. So it's really how you use it.
Maybe two last questions before we move on. Is SHA more secure the higher the bits in it? Is there a sweet spot like economy of scale, at the point at which it becomes less returns, lower returns?
Um, so SHA is a type of encryption. The number normally represents a length. So someone else might be able to tell me this, but I I think there's actually a different encryption between SHA 256 and like a lower one. I'm pretty sure it's a different mechanism. So generally the longer the, for example, seed you might have heard or bit length, yes, it is more secure. For example, I know when you're using your browser, it goes, oh, this is encrypted by a 128-bit key and 256-bit key or something like that. And um, that's a different type of encryption. But to answer your question, I would say generally for some encryption, the bit length, yes, but not necessarily for SHA. It's probably and someone can actually correct me if I'm wrong here. It's a different encryption algorithm. So
And finally, how does quantum technology have any impact on blockchain?
no. Um, I encourage you to have a look at that question's been asked every 3 weeks, and it's been asked for every forum as well. Um, the short answer is it doesn't, and don't believe everything you read. And I say that, but go have a look at the forums, and you can actually see examples from Satoshi Nakamoto himself, the inventor of Bitcoin, talking about how this isn't a problem and how it would be fixed. So when in 2010, when they were first talking about this, they have a solution. And to sort of bottom line it, it's not a problem until it's a problem, and it's not a problem right now. So it's just media hype right now. So
Cool. Well, let's onward into the fray.
great. We also have another question section at the end. So
Yeah.
if you have questions, please send them through. So smart contract, you've probably heard this term and wondered what is a smart contract and where do I sign? Well, no, that's not actually what a contract is. A smart contract is a self-executing agreement written in code. Code is programming language. Code is the same thing that runs this website, has built this piece of software. Um, and this particular code runs on the blockchain. It's put in as part of the blockchain and automatically enforces terms when conditions are met. And I'm going to be really brutal, if this, then do. So if this price of Ethereum equals this, then do that. Or if this time is at this, do that. And I'm being very general there. You can actually run different code enforcing different conditions. And it runs with no intermediaries. So once you have deployed it, it's out there. You cannot stop it. It's autonomous. It will run forever. If it breaks, it breaks. But as they say, code is law, meaning it does what it does. and no one can stop it. It's actually immutable code, meaning if you write it and put it on the blockchain, just like if you put a hash there, it's there and it's there forever. So it better be correct because there's no coming back if you get it wrong. So how do smart contracts work? This is a very popular image, but they're written in a programming language. There's various different ones. I won't get into that right now. And as I've said, it's deployed as immutable code. And we've talked about immutable data. And if you're wondering what the word immutable means, it just means it's something that's said and that's the fact. It can't be questioned because it's immutable. It's a fact. So you write this code, it goes to a public blockchain and it's viewable and it runs as the conditions are set. So it's triggered by transactions and it can't be changed once it's live. So how smart contracts work? Immutable code means get it wrong and you can lose a lot of money or break things. So you could actually transfer things the wrong way. It could have a condition that if something equals 0, it stops working. So code fault errors have caused a lot of leakages and losses. And then I guess if you wanted to talk about security, a lot of, and I dare use the word hackers, look at smart contracts and look for bugs, weaknesses, vulnerabilities, and can exploit that by looking at what would happen if I sent this many pieces of cryptocurrency to this smart contract, or under this condition during this time in this situation, the money will leak out somewhere else. So it's very, very important to and there actually are companies that audit code before you put it out there and will give a guarantee of you pay a bit of money for that, quite a bit of money actually, but they'll validate your code for you. Developers can program in kill switches. So, for example, every 1 minute, or maybe not 1 minute, every hour, go to this API call and have a look to see if on equals true or on equals false. And if on equals false, don't run anymore. But this reduces decentralization and you're absolutely killing the trust of having immutable code, because if you remove immutable code from the blockchain by creating a kill switch, the trust then gets switched to the developers. So the developers might, and it could be more than just a kill switch. You could have some other external code or some other entities, but you have to then say, well, I trust the developer of this smart contract or the deployer of this particular function on Ethereum to honor what they've said. So it removes a bit of trust, and it is not always the best thing to do, but it has happened. So what I want to talk about is what smart contracts cannot do. And don't be confused with the word contracts. It's not a legal document. It can only enforce what the code says in it, but it could enforce potentially a legal agreement. So if you agree potentially in an escrow situation, you could potentially use a smart contract there to say, if the truck gets to this point, pings the API, then release the money, something like that. So they cannot access external APIs, and I know I've just said APIs, and we'll get into the reason in a second. And I'm using that just to make the example easy, but they can't directly talk to APIs, but they do it another way. But we'll talk about that in the next slide. They can't change once deployed, unless designed with upgradability, which is the kill switch I've just talked about. they can't understand content or context or intent, so they only follow the code that's put in front of them. They can't fix themselves. They're not magical. They don't know what it should do or what the general meaning of this is. There's no judge that says, well, that's not the intent of the code. The code was supposed to do this. No, it'll do exactly what it says, and that's only what it will do. It doesn't matter if it's right or wrong. It will do what it says. So it cannot enforce off-chain actions. It can only look at what's in front of it, and that's the code that's on the network. And it obviously can't handle subjective situations. So if you say that's not fair, it does not care. It's code. If code is law, it does what it says. So smart contracts benefits, it's automation. If you assume you've written the best smart contract ever, you could put it out there and it will run forever and ever and ever and never stop, assuming the blockchain network that you're on has not stopped working. But essentially, it will run forever. All logic is on chain, so all the code is there. There's no external dependencies. You don't have to keep a server running. It's there. It'll work. It's hard to tamper with. I'm not going to say it's impossible, but assuming you've written good code, security is baked in. Obviously, new vulnerabilities are always coming out, so you have to be careful. And then cost reduction. You're getting rid of middlemen. It's out there and running by itself. There's not a person that needs to sit there and press a button, listen to something else. That it's total automation in a decentralized method, code on a blockchain. So some examples. I'm just going to quickly, and I encourage you to go look at these just because they are advanced topics. Decentralized finance or DeFi. So there are, and I don't want to go into this, it's too crypto. You can do loan swaps and yield farming on particular networks. NFTs, which I'm sure everyone has heard of. They are minted. Minted means created, and royalties are paid via smart contracts. So, for example, an artist, if you're not sure what an NFT is, I encourage you to Google that right now. But if you're an artist that's created something, you can take a percentage of sale. So, and you bake that into the smart contract that if it's sold on a public network or even resold, a certain portion of that money will always come back to the artist, and that can be baked in using a smart contract. Escrow or escrow, funds are released only when goods are delivered, as an example. And then DAOs, governance by on-chain votes, which was a question we had before. So you can actually run voting on a particular topic, voting on a particular feature of blockchain. I know that voting for particular upgrades on the network for particular blockchains are done via voting, and it's all done on chain as well, so it's very transparent. So smart contracts and APIs, and I know I've just mentioned that they are not compatible, but smart contracts use oracles, and oracles are services that bridge smart contracts with off-chain data. So if I say a smart contract uses the API, I'm just shortcutting it because ultimately, if you Google that, it'll probably say, no, it's not possible. But smart contracts use oracles, and oracles are services that do this bridging for us. They talk to what needs to be said to, for example, an external API, and then they translate that to what needs to be told to the internal smart contract. So how they work, smart contracts request data it can't access. Take an example, stock price, weather, status of an order, whatever you want to do. The Oracle fetches it from an external source, API, website, sensor. So you could have potentially an IoT device or a small mini computer, or even, excuse me, what do you call it? A barcode scanner that says that package came to this port. You could have an IoT mini computer in a storage container that blips to say, yes, my GPS coordinates is this place, and sends it back to a centralized server. where the Oracle fetches it and finds out, yes, my shipment of whatever has reached this port and it's immutable because I trust the computer and it's on the network. So, and you could have, okay, well, it's reached this port, I will release the money or release half the money or whatever I need to do. So there's a lot of things you could do there. The Oracle sends the data on-chain, triggering the smart contract. So the Oracle, as I've just said, says, here's the data. The smart contract pulls that into its code and determines what it needs to do with that information, depending on what the contract says. And the contract uses the data to execute the logic. So exactly what I've just said, it unlocks a payment, it sends an action, it alerts a user, etc. It could even, if you wanted to, go through another Oracle to send you a message to say, hey, this is done. So I've used the word oracles, and what is oracles? So built-in oracles, you can write Oracle logic into your own smart contract, but it still needs someone off-chain to feed it data. So you still need, if you're writing the Oracle, it doesn't automatically get all this information. It needs to connect, for example, to weather API to say XYZ. It doesn't get it automatically. External Oracle contracts, most often your contract will talk to a separate Oracle contract. So there's an example of that through Chainlink. So you're gonna, I don't want to get too deep into this. You can use a different Oracle chain network to generate trust, but that's one way to do it. And then the off-chain components, Oracle usually indicates off-chain software. So that's that middleman that's connecting to the Oracle itself. So you might have a few, so the smart contract, the Oracle, the middleman, the API, you might have a few little things between getting the data into it. So example, your contract requests a price, Chainlink, in this case, the Oracle, fetches the price from a real API and they send it back to your, so if you were to, for example, okay, all of our money is in USD and the shipping provider wants to be paid in Japanese yen, you could actually request the exchange rate from a server that's been set up to provide that and pay at the exact rate of that day at that time, and all that information would be available to pay the shipping company or pay whoever you need to do. So there's a couple examples there, and I'm really just stuck on the supply chain examples there. So on-chain, getting into on-chain and off-chain. On-chain data is usually stored directly on the blockchain, as we talked about. Data is stored outside the blockchain with a reference hash is off-chain. So on-chain data, permanent and tamper-proof, transparent and auditable, accessible by all smart contracts because it's online. But zero privacy, it's out there. Don't put privacy data out there. Everyone's going to see it. So it's also expensive. The more data you put on chain, the more expensive it gets. You cannot put large files there. You could, but you can spend a lot of money. It's slower performance because it's on a chain. It needs to go get it. It might need to assemble it. It might need to decompile certain things. So it's not necessarily the best. Off-chain storage is cheaper and scalable. An example is IPFS, and I encourage you to look that up. It's a blockchain file system, but it uses off-chain elements and on-chain elements to allow that to work. It's faster to handle larger files, obviously, because they're not particularly on the network. It's very less centralized. You have to actually trust that the file is there, it's available, it hasn't been taken down. There's no way to prove that until you go look for it. So it needs external systems. And then data integrity needs to be verified. So, and just as I talked about NFTs, it's a very, very good example. The For an NFT, I encourage you to look that up. It's a trend that I don't know if it's still popular, but it was. And most of the metadata was stored online. So the properties of the so the name of it, the number, maybe the properties of what the image has, that part was stored on chain. But the actual image or maybe video file is usually, and I say usually because there are a couple of examples where it was on chain, is stored offline, and that's stored on your typical AWS server or anything like that. Even IPFS was used very commonly. Um, so on-chain, as I've just said, token ID, ownership, metadata, and a hash. The actual content, the JPEG is stored on web servers or IPFS. So we do that because it's too expensive to put it on-chain. The other thing is that if your image is offline, there have been concepts of dynamic NFTs where they actually change the image, but then you get into decentralization and trust issues, but there's different examples of that. So I'm conscious of time, so I'm going to go a little bit fast. How smart contracts connect to the real world. Smart contracts on chain can't reach the outside world directly. They rely on the oracles to connect with external systems. The on-chain contracts store the hash for the most part. An oracle or an off-chain agent checks the hash, validates the data, and checks with the real world systems or the APIs to determine the information that's available to the smart contract. And this allows the smart contract to react to real world events securely and automatically. And I've sort of said, why does this matter? And it enables decentralized apps and sometimes called DApps to bridge blockchain logic with real world actions. So we've got the concept now of immutable data that's offline through a hash, immutable code, and immutable code that talks to real world APIs. So you can see how we've potentially built on the particular topics. And I know there's a question about legacy systems. So legacy systems, and I've used the word, it's an expensive lift to put legacy systems online. So if you have a Cobalt system in a basement, how are you going to verify any of that data? Well, you don't have to. You just have to put the hash of it online and create a smart contract that connects to the API to say, does this validate the real world data? There is some trust issues there, but you have put a legacy system online without exposing any of the data and putting immutability up there. So if that is a business case that you want to do and you have a legacy system that to lift that, to upgrade that system would be too expensive, you can hash certain elements of it and make that available on a public blockchain. Excuse me. So you can certify records without exposing the full data. Select parts or proofs like hashes that are public that put on there, keeping some of it. So you could hash the actual transaction, but not the data within it. And then I've just used the word technical lift as lightweight. Existing systems just need to compute a hash. I'm going to skip the wrapping part because I know we're running short on time, and I know you've got some questions. So next week we're going to look at zero knowledge proofs, and it's a very, very interesting concept, but it's building on what we've talked about in the last 3 weeks. We'll look at the security, trust, risk, immutability, some other examples, interoperability between different blockchains, and potential opportunities of what's coming up next. So I want to make sure there's enough time for questions. So if you have
No
questions,
problem.
please fire away.
We have indeed. Can a blockchain have more than one smart contract, i.e. many pieces of code?
Yes, it can. It can have as many as it wants. You as an individual, as a contributor to that blockchain, can put as many up there as you want, and anyone can do that.
This is a follow-up question which I don't quite understand. It may also be necessary to allow more than one smart contract on a blockchain to negate the effect of a fault of the previously deployed immutable smart contract.
Yes, but I mean, in theory, you shouldn't have to do that. But in practice, I know it does happen. So, you're not wrong there, but it sort of negates the trust of the entire project at that point. So, um, I'm not saying that you wouldn't do it, but you might run into other problems. So,
And how or who enforces these smart contracts? I assume they're just enforced
the
by
code
running them.
does. The code does. It does. The code does exactly what it says. It
Yeah.
won't do anything else. It does exactly what it's supposed to do, and that's it.
Okay. Saying smart contracts are the web services running in the cloud is a correct analogy?
No, they run on the blockchain. Obviously, if you really want to get into it, there's little virtual machines that they run in, and they're part of the nodes that make up that network. And they run in a closed, and I'm using the wrong word here, sandbox environment that runs the particular code, and that's how they work. They're not like I guess they're not web servers, but they are computer nodes that are connected to the blockchain network.
Is the use of blockchain in healthcare typically implemented in a consortium type approach, i.e., the transition of electronic health records from ClinPath, clinic, pharmacy, hospital, patient via MyGov, My Health Record?
I think they'd like to do that. Um, in practice, I don't think they're doing that. But I don't know if they're doing it. I use that example because it seems like a very good example and something that could really work. In practice, um, there's not a lot of money in healthcare, and a lot of IT budgets get swallowed up by expensive doctors and equipment and stuff like that. So I would hope that it is being used, and I'm sure it's being used somewhere in the world. I just can't particularly point to an example right now.
Okay. Uh, Oracle questions. Is a miner a type of Oracle? Apart from accessing real-world data sources in case of Oracle and smart contracts, it seems that like they play different functions.
They play different functions. You deploy the Oracle as part of the smart contract, which is deployed on the network. And but I don't want to get too detailed into that, but yeah, they are different.
Okay. And is the Oracle also a if this then do code?
That was a very simple. It's not, and I encourage you to go look at the code. It is real code. I mean, obviously, it's not going to play music or anything like that, but it's specific code. It's not just if statements. There's other statements, functions, subroutines, things like that. So yeah, it can do hashing as well. So you can actually use smart contracts to validate a hash. So you could actually use a smart contract to validate a hash that's already on the network. So for example, if a hash was in a particular blockchain, it was already in the public chain, you could look that up and then use an oracle to look that data up from an off-chain source and then compare the hashes or even hash in real time. So yeah, there's a lot of functionality with that code.
Who does the coding part for the smart contract? Are they unique?
Developers all around the world do it. So yeah, I also encourage you to, if you're interested in a developer, to look into that. It's a very lucrative industry, but don't get it wrong, get it right. Do your testing on what's called test nets, and have a look at, do your research. Have a look at past failures or past examples. Have a look at successful code. Have a look at how people, when auditing the code, what they're looking for. Have a look at audited code if you can. It's all public. So I encourage you to have a look at that if you're interested.
Okay. By the way, to everybody, we will be shutting off the questions in about 5 minutes or less, and we've only got two or three to go. So if you've got some more questions, bung them out. We're getting the same question twice, which is how much do you think we'll be using blockchain in our everyday lives?
Um, I think you'll be using it and not even realizing it. Because unlike, for example, AI, where everything is powered by AI now, and it's a very big thing. It's blockchain technologies turning into a tool that can be used to create safer, more immutable environments. So I think you may do some bank transfers in the future. You might do some, um, you might share some documents somehow, and it just will use that technology and it will become part of the technology slash computer internet ether. And you won't even know that you're using it. So I personally hope it's used more. I think it's got a lot more use cases. It kind of gets a bad rap because of the cryptocurrency attached to it. Um, excuse me. But hold up, I'm gonna cough.
We do need a good cough button on this thing.
Too. So yeah, I mean, I hope it's used more, but time will tell.
Okay. Here's a bit of a doozy. Are there emerging standards or legal frameworks in Australia for smart contract enforceability or DAO governance?
Um, yes and no. I've got a cough more, so I'm dying here. Sorry. Um, yes and no. There's been a lot of regulatory talk about blockchain, and I know the Australian government put something out recently, and I haven't looked at it because it only came out recently. But they've been trying to regulate it for a while, not necessarily around smart contracts, but what you can and cannot do, what defining exactly what cryptocurrency is, what's um sorry,
Maybe,
my voice.
maybe while you take a bit of a break for a cough, I will do the. We've got a few more questions coming up, everybody. So please stick around. But I will again remind everybody while we are giving Rich a chance to have a glass of water that there is a survey this week, and we really would love you to fill it in and give us your feedback. We're always trying to improve things. So please go to learn.itmasters.edu.au, and when you log in, it'll be there. And in fact, John has very kindly put a direct link to the survey. It's seen as a quiz in the Moodle platform, but it is actually our survey. The other thing I would remind everybody about is that, one of the reasons that we're able to do these free short courses is that we actually run paid postgraduate degrees in various areas in IT, primarily cybersecurity, cloud, networking, with an MBA, things like that. And the part of the cost of coming along is to hear us talk about that. So if you've got any interest in studying postgrad later on, and studying postgrad doesn't mean sitting there and doing research, as you heard Rich say, he did his masters with us a few years ago. It's about extending your work options, I think, as much as anything else. So just have a think about that. Have a look at our website and maybe get in touch with our people. If you're not sure if you're really in a position to do it, you can always fill in our eligibility form, and we'll tell you whether you're able to be, to be accepted into a graduate certificate or a master's or something like that, because that is where things go. So we've got about 6 more questions. How are you going, Rich?
Yeah, I'm okay now. Sorry about that.
No worries. Did you finish the question about the legal frameworks?
Um, so it's not as I said, the word contract is not a legal contract, so it's more about defining assets that's on it and jurisdictions. So it's not necessarily connected to the word contract. Contracts are only enforceable by the code that's in it, not legally. So hopefully that answers your question.
Okay. What considerations should be made when choosing between on-chain and off-chain data storage in a blockchain solution?
The type of data, um, how much of it you have, how private it needs to be, um, and how much accessibility do you need to it? So uh, that's probably the questions you'd ask yourself.
Okay. Here's one from Sudan, which is close to my heart. Are there any good recognized certifications that you can do for blockchain at the moment?
Maybe IT Masters might have one in a few years. I'm not
Maybe.
sure. Um, Definitely this course. There you go. There's the correct answer. Um, but I don't know any off the top of my head that I could recommend right now.
Apparently, Don says Osaka has a blockchain cert. So there you go. As if it's Osaka, it'll no doubt be very good as well.
There are some short courses that I know about. I just don't know them off the top of my head. So yeah, perhaps
Sure.
a
Maybe you
post in
could
the
pop some in the
yeah in the
yeah in the forum.
forums. Yeah.
That'd be great. Can you share the key difference between layer one and layer two blockchain solutions? If we're going to discuss in the module, we can wait till next time.
Um, I think we'd be here for a while. I will dedicate because that's a very good question. I'll dedicate a couple slides next week just for that.
Okay. Thanks, Harris. Are we able to catch anybody who modifies the code for illegally verifying their own transactions?
Um, it would be super obvious. You can't necessarily turn a wallet into a person. You don't know who it is, but you could definitely say that wallet did it. And if that wallet, because of immutability, had was part of, say, for example, they put up donations or something, you could connect it to a particular person, but if that wallet had never been used before, um, and we're trying to do, for example, a double spend, it would be very obvious who's responsible. It just due to the nature of an example, Bitcoin, the anonymous part of it, you wouldn't know who it was, but you'd know, I guess, the wallet that was doing it. So you couldn't identify the person, not necessarily.
Are APIs used for oracles any different than any other APIs?
Um, no, they don't need to be. Um, it just depends on how the Oracle works. If you're using something that's pre-baked, you might have to create the API so that Oracle works with it. But if you were making your own Oracle, you could write it to work. And I say most of the time, I don't know, there could be examples not. Um, you could write it to work with an existing API.
And finally, as we'll close everything down for this evening, we're rapidly approaching 8:45. If a company would like to track product authenticity from a manufacturer to the consumer, what type of blockchain architecture would you recommend?
Um, well, it depends who needs to see that data. If all the people within that supply chain did not trust each other, I'd do it on a public network. It'd be more expensive, but the trust would then be associated to the public network. If there was, and the public didn't need to see it, say, for example, all the people in it trusted each other, and all you wanted to do was track the source. So, for example, when the consumer bought um, a kilogram of beef and it had a barcode on it, they could scan, or QR code, they could scan the QR code, and it showed them the source of this, and it was immutable while it was verified because it went on this network. Um, so if there doesn't need to be that high level of trust and the consumer or the end user trusted the network, you could use something that's potentially private even. So it just depends on the level of trust and where that trust is with the people that are saying this is it exactly what it is, or whether it's like, for example, a shipping example is the most where ports and boats and sea captains and all these different people don't trust, and different rules between different countries, and no one seems to trust each other. Um, that would be a good example that needs to to move the trust layer to a public blockchain. So
That would be a
hopefully that
really
answers
good
your
one
question.
because
Yeah.
historically, container shipping is heavily dependent on paper-based uh, receipts, etc. more than any other
Yep.
form of transport I've ever seen. Okay, well, that's where I think we'll leave it for this evening. Thank you so much, everybody, for giving us your time this evening. We really appreciate it. It's been really good, Rich. I've been enjoying it, and we'll see you all back again next week. Same blockchain time, same block channel. But yeah, please fill in the forms. Sorry, fill in the survey, and ask lots more questions in the forums as well. I know Rich has been saying there's been some great stuff in the forums, and we'll look forward to seeing you in 7 days. It may be me, it may be somebody else doing the hosting next week, but we'll be excited to finish it off next week. Thank you again. And thank you very much, by the way, Richard. And thank you to John, who's very quiet in the background there.
Thank you.
Okay, good night.